Hi guys, this is Miss Kubon, and today we're going to take notes on energy pyramid notes. So get your pen and pencils ready and let's go. A food chain is a series of steps in which organisms transfer energy by eating or being eaten. Arrows go in the direction of how energy is transferred. You start with the producer and end with the top consumer or carnivore. So as an example in this picture, you have the grass, which is the producer, and the grass ends up in the belly of the cricket, so its energy is transferred to the cricket. So the cricket ends up in the belly of the frog, so its energy is transferred to the frog. And finally, the frog ends up in the belly of the raccoon, so its energy ends up in the raccoon. So here we have a food web. Food web is a network of food chains within an ecosystem. So you see the arrows point to the energy. And then the arrows show us what is being consumed and who is doing the consuming. Which of the organisms above is a producer? The grass. Food webs. Here's an example of a food web in which you can see microscopic algae, or we learned in class phytoplankton. And you have the seaweed-like organism over here that is again the producer. How do you find the producer? The producer has no arrows going into it. The producer gets its energy from the sun. We do not see the sun in this food chain, but the sun's energy is the energy that begins the food chain. And as an example, you see which organism feeds on what. So what would happen if an animal or organism was taken out? So as an example, if the crab were taken out from this food web. So we have a question, what would happen to the flatwinkles? The flatwinkles, which ate the bladder wrack, the flatwinkles are just fine. Oh, but now that the crab is not there, the flatwinkles are not being eaten. So their population would increase. And then let's see what another result would be. Oh wait, the herring gulls, they lose out on food, so their population would probably decrease. So again, the flatwinkles, they didn't get eaten, so they increase. The herring gulls would have less food, so their population would probably decrease. What we're going to look at here is trophic levels. Trophic levels are each step in a food chain or a food web. Another name for trophic levels is energy level. So level 1, producers. Another name for producers is autotrophs. Autotrophs comes from auto, meaning to do yourself, like an automobile propels itself, and trophs is a level of food. So we have, in this case, this level of food can make its own food. Autotroph is a term you definitely need to know for high school. Level 2, primary consumers, herbivores. Level 3, secondary consumers, which are carnivores or omnivores. Level 4, tertiary consumers, carnivore, usually a top carnivore. So what you need to notice about the levels is because we start with producers, once you kind of have the number words like primary, secondary, and tertiary, those do not match their level. Primary is actually at level 2. Secondary level 3, and tertiary level 4. So just remember when you're doing trophic levels, because you start with producers at level 1, the numbers don't match the words. Ecological pyramids. A diagram that shows the relative amount of energy or organisms contained within each trophic level of a food chain or web. So here we have two different representations, and they're showing you that it's very broad in the bottom, but it narrows to the top. And what we're representing is at the bottom you have producers, then primary consumers, secondary consumers, tertiary consumers. This is a two-dimensional image, and then this one is three-dimensional. So you can show how much is contained, the energy of the producers, energy of the primary consumers, energy of the second, energy of the tertiary. You should notice that it's going down. Energy pyramid shows the relative amount of energy available at each trophic level. So let's look at what that means. So in order to form an energy pyramid, you need to take into account that organisms in a trophic level use the available energy for life processes, such as growth, photosynthesis, cellular respiration, metabolism, etc., and release some energy as heat. So what does this mean? Organisms use their energy to live. And some of the energy that they use to live will be released as heat. Remember, every chemical process that happens in your body releases heat as a byproduct, like burning calories. The rule of 10. Only about 10% of the available energy within a trophic level is transferred to the next higher trophic level. Okay. You are burning 90% of the calories that you eat just to stay alive. Only 10% is available to be transferred to the next higher trophic level. And a biomass pyramid represents the amount of living organic matter at each trophic level. So let's look at an example of this. So here you have an energy pyramid. So what you should see is that the grass has a lot of energy available to it. And then you would have the insects, which would be the first order or primary consumers. They have less energy. And then you would have the energy of the second order consumers, or the frogs. And finally, you would have the energy of the snakes, or the third order consumers. So what we do is, this is a different picture to represent it. You can go from 100% of the energy being available in the producer to 10% available in the caterpillar to 1% available in the blue tit, and then finally 0.1% available in the sparrowhawk. So for each amount of energy available in the producer, by the time it gets to the sparrowhawk, 100% has become 0.1%. Okay. This picture represents the amount of energy available at each level, as well as the amount of living tissue. That the tissue decreases with each increasing trophic level, because your energy, as an example, is going from 1,000 to 100 to 10 to 1, because you are losing energy. 90% is lost and only 10% is kept. Because you are losing energy, the amount of organisms at each level will go down. So let's say we had 500 blades of grass. For that, you would only have 1, 2, 3, 4, 5, 6, 7 crickets. And then to the next level, that would only be 2 moles. And then that would be 1 hawk. The energy is decreasing at each increasing trophic level, so that the number of organisms is decreasing at each trophic level. Okay, I hope these notes have helped you. Be sure to get them written down and have them ready for class. Thanks. Goodbye.